Okay. All right. So what would you like to do? This is what mom sent me.
Yeah. I would say I understand derivatives, which we covered in 5.1. But I couldn't define any of it, and that's kind of the annoying thing. I would probably start with chain rule and go
Okay.
up there because
Okay.
I understand derivatives. So,
But not the you mean like basic derivatives, you don't understand the rules.
no.
Okay. Okay. So the chain rule on your IB syllabus, I'm sorry, on your formula booklet, I find confusing
Yeah.
for students. It's like, what? So I'm going to give you a non-mathy rule for you. Okay. And so let me give you a couple of examples here. I'm not sure what textbook you use.
We don't use a textbook.
Okay, you poor thing. And where's your school?
In the UK, west of London.
Oh, okay.
Yeah.
And so you're usually in London,
Yeah.
but you're on holiday?
Yeah, I'm at home. I'm from Belgium, so I'm just
Oh.
yeah.
And is that, forgive me, I have to know your accent. Is it Belgian?
I would say I have a mix of Belgium and the UK, and then some American slips in sometimes too. It's a weird one.
It's awesome. I love it. Because us Americans are just like, I don't know, whatever. Okay. So here's the chain rule in layman's terms, for lack of a better phrase. Oh, and one more thing. Are you generally a really good math student, okay, or a poor math student?
I would say I'm okay, but I'm not good at algebra. Like the actual hard parts of algebra, I'm not good at.
Yeah, you poor thing, jumping around. And you like math? I hate math.
If I can do the math, I enjoy it. If I don't get it, it's so frustrating. So kind of in between.
It is. Okay. Yes. That helps me. Okay. That's why I asked that. Okay, chain rule. Derivative. Take derivative of outside function, then multiply by the derivative of the inside function. That's the chain rule.
Okay. That's recognizable, actually.
Good. So let's take a look at A. And what do I mean by outside function? What do I mean by inside function? It's fairly straightforward, but I'll show you what students have trouble with. So forget about this for just a second. So if I had, I don't know, y equals z to the fourth power, what would the derivative of that be?
For Z or Z to the third power.
I love Z. I haven't heard Z for a while. Okay. 4Z to the third, right?
Yeah.
Okay. So that's the same thing that's going to happen here. Okay. The outside function is the power function. That is the fourth power. That's what I mean by outside function.
Okay.
And I do this example because while I'm taking the derivative of the outside function, I do absolutely nothing to the inside function. It's just hanging out, waiting to do something. Okay. So does your teacher care if you do y prime or dy dx? Does it matter?
Y apostrophe.
Okay.
Like
So I'll call that y prime. It's just in my head. So y prime is going to equal 4 times x squared minus 2x cubed, just like we did to z. Okay. So now I'm done. I'm done with the 4. I'm done with the 3. All good. So now I'm going to multiply by the derivative of the quote inside function. Well, what's the derivative of x squared minus 2x?
2x minus 2.
Done, 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 done. Chain rule is done. Okay. Now, you and I know that it's not always going to be as simple as that. For example, here.
Yeah.
So we have y equals 4 over square root of 1 minus 2x. And we could take the derivative of that using the quotient rule, because it is a quotient. But number one, quotient rule is the worst of them all, usually for students. Number two, we would still have to use the chain rule to take the derivative of this nonsense in the denominator. So we're going to, before we start taking the derivative, we're going to rewrite it in a form that we can just use the chain rule. And that's going to involve moving this guy up to the numerator. Okay. So the first thing I'm going to do, and this is all the time when you're taking derivatives, I'm going to rewrite the square root of 1 minus 2x as 1 minus 2x to the 1/2 power. Is that okay with you?
Yeah.
And do you know how I could move this guy up top?
Do you bring it up and then negative the power?
You are lying to me. You are good at algebra.
I learned this last week.
Oh, no, you need to be quiet about that. You should take the compliment and go, yeah, oh, yes, I'm being a little humble. Okay. So when taking derivatives, coefficients, they just stay there. They hang out and wait for something to happen to it, right? So they have no bearing on the rules of taking the derivative. So now my outside function is the negative 1/2 power, right? Okay. So we're going to start the chain rule. And so you want to take a crack at the first step here?
Yeah.
Okay.
-2.
Yay.
And then keep the same in the brackets. And -1, so -3/2.
Good. How are you with fractions?
Decent, but it's not like super speedy, you know, it takes me a second.
Listen, you're better than any person who learned fractions in the United States, because we just don't like them.
I had that for a year, right? It was bad.
Yeah. Have you sat in a classroom with American students and just look at them like, what's the matter with you?
I did algebra 2 in Florida. And
that's where I'm from.
Oh no, yeah, it was pretty bad, but
woo, it's our fault. It's our educators' fault. I take full responsibility, but I can still complain about it. What part of Florida?
I was in Jacksonville.
Oh, okay, I'm in Orlando, the Orlando area. Okay, so we've done that, right? And now we have to take the derivative of the inside function.
Just -2.
Good. Okay, so if you're only asked to take the derivative, which is rare on IB, and even if they did, they would say, show that the derivative of this function is equal to boom, right? And so they wouldn't leave it in this form. Okay. I'll talk more about what you can and cannot do on your exam, and still get marks. So first thing I'm going to do to clean this up is -2 times -2 is 4. Is that okay?
Yeah.
Okay, and then we still have the pesky -3/2 to deal with. And it's real important, in addition to getting the full marks from showing it's equal to about what we're going to get to, you're going to, the reason you take a derivative is to plug in a value of X and evaluate it. So I don't know about you. I can't, well, I could, but it's more difficult for me to plug it in like this and think, what does the heck does -3/2 mean?
Yeah, I couldn't do it.
Okay. So now we have y equals, and you agree it's going to go down below?
Yes.
To be positive. And just for the notes, maybe you already know how to look at it in your head, but maybe not. I don't know. Do you know how to write that as a radical expression now?
No.
Okay. All right, so let me move this guy out of the way a little bit. I'll do like side notes in green for you, like little scrapwork or whatever. Okay, so here's the rule. The nth root, oh no, let's do it this way. Any base to a fractional exponent, m over n, can be written as a radical like this. The denominator is what we call the index. So the nth root of the base raised to the m power.
Okay.
Okay. All right. Which we can also write, and it just depends on what's going on when you have to evaluate it, whichever is simpler, whichever form is simpler to evaluate. The n is always the root and m is always the power, but the power can go inside the root or outside.
Okay.
So it just, you'll see as you move forward when you're evaluating when something, like if you have a 25, it's the square root of 25 cubed, which is actually sort of what's going to happen here.
Mhm.
You don't want to cube 25 and then take the square root, right?
Yeah.
You would rather take the square root and then cube the result. So things like that. Okay, so now we can write this as, you want to try?
Yeah. So the second root, so square root
Good.
of 1 minus 2x to the power of 3.
Outstanding. Done. Done, 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 done.
Okay.
Okay. I think we should do some practice on this. What do you think?
Yeah, probably. But so I don't understand what is the benefit to the examiner of having it in that form rather than the form before?
Well, here's what's going to happen. I'm going to say with 99% certainty, they're not just going to say, find the derivative. What they're going to do is you're going to find the derivative and then you're going to do something with it, right?
Okay.
So this would be a part A. Show that the derivative of this is equal to that, right?
Okay.
And then in the second part B, they're gonna ask you a question which you don't understand yet. I don't think, where you would have to use this to answer the question by plugging in a value for X.
Okay.
So they accomplish two things there. Number one, they see if you can do it, right? And number two, and this is one thing I really like about IB, is if you cannot show that it's equal to this, you can still use it in part B, right? It doesn't stop you from getting points from part B, which
Yeah.
I think is fabulous. Okay.
Yeah.
All right. So let's try some more. Well, we'll start off with how we started before. What do you think about A?
So 2 times brackets 4x minus 5. That's it. And then multiplied by 4.
Yes, I gave it away. And I would probably, I don't know, I can't help myself to do that. There's no need to distribute it at all. This is perfectly fine because on it, you're just going to be plugging in. the next thing is you'll be plugging in for X. I mean, you can or you can't, but you know, it's totally up to you. What would you do with B?
4 times. Oh, B is that way. Hold on.
Yeah.
So I would put 5 minus 2x in brackets, and then to the negative 1,
Yay.
maybe.
Yay. Yes. Perfect.
And then you'd have negative 5 minus 2x to the negative 2 multiplied by negative 2.
Perfect. Let's clean it up a bit.
So that's just 2 times 5 minus 2x.
To the negative 2, right?
Yeah.
Now let's get rid of that negative exponent.
2 over 5 minus 2x to the positive 2.
Very good. Perfect. Let's try F. I'm just trying to hit each sort of different kind. Looks like you totally have it. And by the way, I hope you know that you are my boss, and you seriously, and you need to say, all right, I got it, let's move on, or slow down. You know, you're going too fast. You're completely my boss, and don't be shy, okay?
Yeah, it's when roots get involved and things like that that my mind just gets lost. I wouldn't know where to start.
Okay, so this goes back to the rule that I gave you back here, which is this one. How we can rewrite, it works both ways, right? Someone's very popular.
Yeah, that was my sister, my bad.
No, I don't care. Doesn't bother me. So this is what we're going to do here. We're going to have to write this as a fractional exponent before we take the derivative. So go ahead.
N is 3.
Excellent.
M is 1.
Yeah.
Okay, so 2x cubed minus x squared to the power of 1 over 3.
Very good. Right. So anytime, like, if all you have is a 4th root, a 5th root, a 7th root, whatever, and there's no, you know, this is 1, you can immediately write it as the argument in here to the 1 over whatever root you're taking.
Yeah.
All right, so here we go.
1/3 2x cubed minus x squared to the power of negative 2/3 multiplied by 6x minus 2x. No, 6x squared, sorry.
I'm so happy because then I didn't have to yell at you. So let's clean it up. And I mean, get rid of the negative exponent, simplify anything we can. I don't see anything we can simplify though.
6x squared minus 2x over 1/3 2x cubed minus x squared to the power of positive 2/3.
Good. Now, I'm not sure what you meant by 1/3. 1/3 does not go in the denominator.
1/3 at the top, yeah.
It's just and the ones up here, which we don't use anymore. Is that right? Okay.
Yeah.
I knew you were good with fractions. Okay. 2/3. It's so refreshing, honestly. So now let's write that in in radical form.
So cubed root 2x cubed minus x squared, and then to the second.
That's it.
Okay.
Really, really good. Really good. Really quickly. Okay, so D, I know you could do. E, I know you can do. We just did F. For this one, you would bring this up and raise it to the -2 power.
Yeah.
This one, it's just a little bit larger of an argument in the middle.
Mhm.
That's different. Are you okay with that?
Is it pretty much the same as otherwise? You just do it more
Exactly the
times?
same.
Okay, yeah, that's fine.
Exactly the same.
Yeah.
Um, let's just finish it up with I.
Yeah.
It's slightly different, but it's a lot of fun.
Okay.
Okay. I think I'm really funny, so you might if we keep working together, it's just a warning. All right.
Okay, I would say 6 times everything in the brackets to the power of 2, so squared, multiplied by x, no, 2x minus um, I don't know. So minus 2x minus 2x to the -2.
Right. So it's -2. Yes. Yes. Right. So what I would suggest, and we're going to clean that up in just a second, is before you start taking the derivative, look at that and say, ooh, I better rewrite that.
Mhm. It's the little rules like that. It was the same earlier, with the 1/3 being 1/3, the little rules that you should learn in algebra that I never did, but just always
I
get me.
know. I know. That's awful because you understand the calculus.
Mm.
So, but you're seeing them now, right?
Yeah,
And so if you did that, you would immediately make it positive because a negative times a negative is positive, right?
right.
And then you're done,
Okay.
right? And
Yeah.
we could write that as 2 over x squared, but for now,
Mhm.
okay. So have you learned what the derivative is? Like the derivative is the slope of the tangent line to the curve.
Yeah, but as soon as he started doing that, that's when I really got lost. That's when my teacher really lost me.
And that's probably because you couldn't take the derivatives and you couldn't get past that, is my
Yeah,
guess. That's my guess.
yeah. And then it was also just the whole thing with sine and cosine, and that started getting into it. And I didn't learn trig as much either. And all of it just confused me. That's kind of it.
Okay. Okay. Um, let me look at some other, that's pretty much it as far as chain rule.
Okay.
And we can get to the sine and the cosine. You're going to be fine. If we keep, if we have time to keep meeting. It's not, well, you don't need to know the trig to take the derivative. So we'll totally be able to take care of that. Okay, so the product rule actually on your formula sheet is not bad. And the product rule comes up when you have two functions that are being multiplied together, like these guys.
Yeah.
Okay, so, and the product rule is there because we could, like, before taking the derivative, we could expand x squared minus 2x to the 4th power by multiplying it by itself 4 times, then distributing the x squared. But by that time, we want to jump off a building. So we don't, that's just too much. Same with the square, we don't want to do that. So product rule, easiest of the rules. And these are in non-mathy, well, sort of non-mathy notation. So derivative of first times second plus first times derivative of second. And I will put some notation in there for you that I think will help you. For y equal to u times v. And I think they use u and v on your formula sheet, but then they do the du dx, which kind of freaks folks out sometimes. Y prime equals the derivative of u multiplied by the function v plus the function u multiplied by the derivative of v. So you just do the combinations.
Right.
And it doesn't matter, like, since it's addition, you could do the derivative of the second times the first if you wanted it. It doesn't matter.
Okay.
Okay. Okay. So then for A, we have y equals, let's go ahead and do x to the 1/2 right away. 2x plus 1 cubed. Do you want me to go through it or have you try and do it?
I can try, and if it doesn't work, you can go through it.
Okay. I won't yell at you or laugh, I promise.
Okay. I would say u is x to the 1/2.
Mm-hmm.
And then v is 2x plus 1 cubed.
Good.
And the derivative of u is 1/2 x to the negative 1. 1/2. Oh yeah, that's right. And then
I'm going to stop you right there, just real quick. So every time you have a fractional exponent, like you just did, you have to subtract 1, right?
right, yeah.
And maybe you're doing this, but what I tell my students is instead of, the 1/2 minus 1 is pretty easy, but I don't know, like people, it's kind of 5/13 minus 1. Like, well, don't think of it as 1, think of it as 13 over 13.
Mhm.
Or in this case, 2 over 2, right?
Yeah. Yeah, and then you
1/2.
minus 2.
Right. I'm not sure how you're doing it, and you're doing well, but I always like to throw that out there. So
Yeah, thank you.
okay.
Multiply that by 2x plus 1 cubed plus x to the 1/2 multiplied by, do I use chain rule here? I do, right?
Yep.
Multiply,
Go ahead.
multiplied by 3 times 2x plus 1 to the power of 2 multiplied again by 2.
Excellent. We should clean this up. You're going to have to clean it up.
Mhm.
So we might as well get it out of the way now. And again, to be able to evaluate, plug in something for X.
Um, do I, to get rid of that negative exponent, do I, what do I do?
Put it down in the denominator,
Okay.
right? What I like to do is I know it's fractional because I have the 1/2. So what I like to do is first think, okay, what is staying in the numerator? And the only thing that's staying in the numerator is 2x plus 1 cubed, right?
Right. Yeah.
And then the 1, but we don't care. And then the 2 is down there, right?
Yeah.
And x to the positive 1/2, which if I'm going to evaluate, I'm not sure if you can do this step yet right away. I'm going to immediately, yeah. Okay.
Yes.
This one is a little friendlier. We don't have too much to do here.
So the 3, so I would, yeah, so the 3 multiplied by 2x plus 1 squared times 2 stays in the numerator.
Yeah, they all do. There's no negative exponents.
Oh, that, yeah. Okay.
Yeah.
So multiply it all by 2.
So what would we get?
2x to the 1/2 multiplied by 6, 2x plus 1 squared.
Oh, you distributed it. Okay, so this is all one big multiplication. So you don't take the 2 times the 3 and the 2 times the x to the 1/2.
Okay.
This is like, I have 3 things being multiplied here. They're weird things, but I have 1, 2, 3 things being multiplied.
Yeah.
Right? If they were numbers, I don't know, 2 times 4 times 7, you wouldn't take 7 times 2 and then 7 times 4.
No, that's true.
Right? If there was addition, you're getting it confused with the distributive property, which would be if it was 2 times 4 plus 7, then yeah, right, you could distribute it.
So I only distribute, so it would be square root of x, if I want to do that.
Yep.
Multiplied by 6x plus 3 squared times 2.
Okay, so order of operations, parentheses, right?
Yes.
So I have parentheses, but there's nothing I can do.
Yeah.
Exponents, I don't want to expand that, right?
Mhm.
Then multiplication. So what I'm getting at is you cannot distribute this 3 because of the squared. We haven't taken care of the exponent yet.
Okay.
So the simplest way to write this would be the 2 times the 3 is the 6.
Yeah.
Rewrite x to the 1/2 as square root x.
Yeah.
2x plus 1 squared.
Oh, I didn't catch that the 3 was like its own little thing.
Yeah.
It makes sense.
Is that okay?
Yeah.
Okay. Well, okay, so you might not know your algebra and trig very well, but you're really, really smart. That's clear. So I think once you see it, you're going to be just fine.
Okay.
Okay, so let's try this one.
So that's 2x multiplied by x squared minus 2x to the 4th plus x squared multiplied by 4 times x squared minus 2x to the 3rd multiplied by 2x minus 2.
Excellent. And I would probably just, this is fine, but the math teacher in me says, let's write that as 4x squared, but it's fine. Okay.
Yeah.
That is the product rule. Let's just try a couple. And I'm going to add a little twist for you here. We're going to talk about the tangent.
Okay.
And I'm going to give you some conceptual understanding before we do that. And stop me if you know this. Okay. So I'm not sure if you understood when he derived the derivative, if your teacher did it all. Is your teacher a he?
Yes. Yes.
Okay. So oh my goodness. So you know what a tangent line is?
Yeah, it like rests on the parallel or any line would.
Anywhere, any
Mhm.
curve, anywhere, right? So it touches the curve in one point, right? Let's just say that point right there. And every line has a slope, right?
Yeah.
Okay. So what the derivative gives you, and let's just say that this is, I don't know. This is point A, right?
Yeah.
The derivative gives you the slope of the tangent to the curve. That's the general thing. That's what I nail home. Like if you're ever confused, you go back to mama. That's mama. It's the slope of the tangent to the curve.
Okay.
Okay. Now you use it to find the slope of the curve at the point of tangency. In this case, at x equals a, by plugging in the x value to in the derivative. Okay.
Mhm.
So this is just general. Let's say this is f of x, right?
Yeah.
So if I find f prime of x is the derivative, right?
Mhm.
Whatever it is, some horrible function. This is a quadratic. So f prime of a, which means I'm plugging the value a into the derivative and
Mhm.
evaluating it.
Would they give that
Yep.
in? Okay.
I only used a just to make this is for everything, right? To generalize it. Like
Yeah.
this is for every value of x, any
Okay.
or any possible derivative. So f prime of a is the IB uses gradient, sorry, is the gradient of the tangent to f of x at x equals a.
So the gradient of whatever x is, not the gradient, sorry, the derivative.
Mm-hmm.
Oh, I see. So you would plug in the x value into the derivative of the
Yep.
function.
Yep.
Okay. That
To
makes
give you
sense.
the slope of the tangent
Okay.
at that point. And it can be used everywhere, right? It doesn't for every single tangent line, as long as I know the x value in question, plug it in, that's the slope.
Mhm.
Okay. Furthermore, slope measures the change of the line, right?
Mhm.
How the line is changing. Oh, it has a slope of, I don't know, 5. That's really steep, right? It's
Yeah.
changing very rapidly, right? The same exact thing for the curve. Now, the slope of a curve is changing constantly, right? So what it does and what we say is it gives you the instantaneous rate of change for the curve.
Okay.
Okay.
Just
So
wherever it is.
yeah, wherever. So this could, this curve, this function, and this is why we have mathematics, could be used to model something like, I don't know, the profit of a company or the amount of pressure the outside of an airplane can take, whatever. So it's important to know how that is changing at certain points.
Okay.
So that's like an overview of what it is. And it's important to understand for what's coming with your applications. Okay. So with that, and I'm going to show you graphically because I really think it's important for you to have the whole picture here. We're going to find the gradient of the tangent to this function when x equals 1 or -1, sorry. So y equals x to the 4th times 1 minus 2x squared. So the derivative would be what?
4x to the 3rd multiplied by, yeah. Don't you multiply that by 2 as well?
Oh, no, not yet. Because that's the derivative of the first times the second.
Oh, okay. Yeah,
right?
that makes sense. Yeah.
Okay.
Plus 2 times 1 minus 2x.
I'm going to put x to the 4th first.
To the first, and then times 2.
How about -2?
Right. Yeah, that makes sense.
And I'm going to plug, and now to find the gradient, I'm going to plug in -1.
Okay.
And you don't have to simplify this, but I think it's just one less thing if you just quickly rewrite this as 4x cubed, or maybe not. It just depends on how good your arithmetic is. Minus 4x to the 4th times 1 minus 2x. Is that okay?
Yeah.
Okay. So now we're going to find y prime of -1.
Yeah. So -4 cubed.
Well, no. It's -1 cubed times 4. The only thing that's cubed is the x. The 4 is not cubed.
Okay. Yes.
If the 4 was cubed, there would be parentheses.
Okay. Yeah.
Okay.
Makes sense.
Okay.
Mm-hmm.
So -4.
Wait, why does it become negative?
Because -1 cubed is a -1.
Yeah, times
Okay.
4. Okay.
So here's the thing. Any odd exponent where the base is a negative is going to be negative.
Okay. Yeah. Makes sense.
Okay.
And then 1 minus 2 times -1 cubed squared, sorry, is 1 minus 2. 1 plus 2 is 3 squared is 9.
Yay.
Minus, it's 4, just
Good.
4.
Good.
Times that 3.
Excellent.
Oh god, big mass. -4, yeah, all of that, right.
You're under pressure. That means, and I was going to show you the graph of this one, but it's too nasty. That means the slope to this curve of the tangent line, right, when x equals -1, I don't know, let's just say it's like this, whatever.
Yeah.
Is -48. So it's a very, very steep line.
Is that, you can just call it that?
What do you mean?
You can just call it -48?
Yep.
Okay.
Right? Like if you had y equals -48x plus 7, this is in the form of y equals mx plus b. Are you familiar with that?
Yes.
And as I said, hey, Lot, what is the slope of that line? You would say -48.
Right.
Same thing. Okay.
Yeah.
Now this isn't the curve. I have no idea what the curve looks like. I don't care. I just know that the slope is -48.
Okay.
Okay. I want to do an easier one for you, just so you can see what's actually happening here. So let's do, I'm going to do a simple derivative or a simple function like y equals x squared plus 2x, I don't know, minus 3. So the derivative would be 2x plus 2.
Yeah.
And let's just do at, I don't know, x equals 2.
Yeah.
I'll say gradient.
6.
Good. So that would be y prime of 2. I'm just doing this for your notes. Equals 2 times 2 plus 2, which is 6, right?
Yeah.
Okay. So the other thing I'm going to do now is to find the actual coordinates of this point on the curve.
Okay.
Okay.
We did this in class.
Okay. So I know the slope at 2 is equal to 6, right?
Mhm.
When x equals 2. So that would be the point of tangency, right?
Yeah.
That we're interested in. There's an infinite number of points of tangency, but we're interested in it when x equals 2. So that would be 2 y of 2, wouldn't it? Up to the original function,
Yeah.
which is 2 4 plus 4 is 8 minus 2 5.
Okay. So you just plug in x.
Yeah, I plugged in x. Sorry, y of 2, plugging in x into the original function.
Okay.
Okay, so let's just take a look at that, what that actually looks like. So I'm going to graph it for you. Okay, so I'm just going to do something real quick and you're going to recognize it, but I want to put it in the right form and I can't do it in my head. And I don't want to mess it up. That would be.
So if the gradient is so we figure out that at x equals 2, we have to plug in. I'm kind of confused why the y coordinate is 2 plugged into y.
Well, let me get the graph.
Yeah.
All right. See how clear it is?
Mm-hmm.
Okay, so there's all our stuff, all our
Yeah.
calculus, right? And a little bit of
Yeah.
algebra. And then here's our graph. Okay, so red is the original function,
Yeah.
which is y equals x squared plus 2x minus 3. Now kind of small, I have plotted the point of tangency, which we figured it to be 2, 5. And that's because we wanted to find the gradient at x equals 2, right?
Yeah.
And we found the gradient to be 6,
Yeah.
right?
Yeah.
And we found that gradient to be 6 on the curve, or the point is on the curve, right? At x equals 2.
Oh, so then if you plug that into the original, then you get the y. That
Right.
makes sense.
If you plug it into the derivative, you get the slope. You don't, you get the slope.
Yeah.
Right. And so then I figured out the equation of the tangent line, which we'll get to. But the equation of the tangent line, which is right here in blue, you probably can't tell it's blue, is y equals 6x minus 7. Notice that the slope is 6.
Yeah.
Same as the slope of the tangent to the curve. That's what we're doing.
Okay.
That's what's happening. Okay.
Yeah.
All right. So let's do some more product rule practice. Or I feel like you're okay with the product rule.
Yeah.
I don't think we need to do that anymore, because it's just a matter of derivative 1 times the other and then reverse it and add it and blah. Okay. So then the next question would be, how are you feeling about the quotient rule?
I probably couldn't tell you what it is.
Terrible you're feeling about it, which I don't blame you.
Yeah.
They save the best for last. Here, I'll throw this up there. There it is. Got it.
Oh God. That's a big formula.
Well, it is on your formula sheet. Let me get all the rules up there. You can kind of see them then and what you can and can't use. I mean, it's correct, so I like it, but for students, I don't like it, of how we show things on the formula sheet. Chain rule is indecipherable, right? But product rule, it's u v primed plus v u prime.
Yeah, it makes sense.
Right? That makes sense. Okay. And so the quotient rule is pretty good. If y is equal to a function u divided by a function v. Okay. It's v du or vu prime minus u v prime all over v squared.
Okay.
I'm going to get rid of this the way the book does it. So there they are in all their glory.
Beautiful.
So the nice thing is, for product and quotient, you can follow this. I usually just write it as v u prime minus u v prime.
Yeah.
Instead of du dx.
I'll rewrite all of them.
Yeah.
So
yeah, you can just cross it out on your formula sheet if you want, like, oh, that's not going to work, is it? Like, you know, v u prime, I don't know, whatever is best for you. Okay.
Yeah.
All right. So how are we doing? We can probably get one, maybe both of them in. So a, y equals 1 plus 3x over x squared plus 1. And some people, I don't like to do this, because if I have the formula right in front of me, I feel like I can use it, especially if the derivatives are easy. But some people will do this. they'll go ahead and say, all right, u is 1 plus 3x. They'll just make a little chart over here.
Yeah.
du,
Should
yeah, v is x squared plus 1, and this is 2x. And it's nice, you know, whatever floats your boat. But I just don't personally like it, but that's okay. All right, so according to our formula, v du, so x squared, I'm sorry, go ahead.
X squared plus 1 times 3 minus 1 plus 3x times 2x.
And people think of it like, you know, like a cross. The only problem is you got to make sure you start correctly because it's subtraction,
Yeah.
right? You would have to do that first.
Okay.
Some people do that. All
Okay.
over?
Over x squared plus 1 squared.
Yep. Don't ever expand that. Unless you absolutely have to. There's no reason to expand that.
Okay.
There is reason to simplify this. I don't know. Like if you sometimes, again, IB will say show that it's the simplified part. Sometimes they won't even tell you to take the second derivative or you have to use the quotient rule. You're just going to have to use it. Like they might say, find the slope to this curve at x equals 1, right? Well, if that's all they tell you, you're going to need the quotient rule. And then you're plugging in 1. So you could stop here and plug in 1. You don't have to simplify it. And you get full marks as long as this is correct. But if we simplified it, and please be careful with the minus, because you're subtracting the entire thing, not just the first term. That's why I put parentheses. What time is it in Belgium? Are you like 6 hours ahead of me?
It's 8 o'clock. So yeah,
Nailed
6
it.
hours.
You don't want to be out having fun in Belgium. I mean, this is much better.
I agree.
You are such a liar.
I don't have anything to do. I'm in my grandma's town. I don't know anyone.
Oh, really?
Yeah.
There's like nowhere like there's the drinking, like you couldn't go to, oh, if you don't have a friend, you don't want to go to a restaurant or something.
But I'm leaving tomorrow to where my people are. So I'll go there.
Oh, so that's going to be a whole different, I'm going to see you in a whole different story. You're going to be like tired and okay. Yeah. Okay. All right. So was all that helpful?
Yes, very helpful. Thank you so much.
Okay. And do you think it's okay with mom if I have your email address to send you this to you?
Yeah. Should I type in the chat?
Yes, please. Okay. And so then do you want to schedule a lesson, or are you going to leave it up to mom, or how's that going to work?
I would probably leave it up to mom because
Okay.
That sounds good.
All right. Well, it was nice meeting you and nice working with you, and I hope to work with you again.
Yeah. Okay.
Bye, Lotte.
Thank you so
Bye.
much.
You're welcome. Bye-bye.